Before the fixture can be designed, it is necessary to work out just how this clutch operates, how it goes together, how it failed, and what we can do to make the design better. We know that the hub assembly failed and the retaining bolts failed. There could be two obvious causes of this failure. Firstly, the detents jammed, causing the retaining bolts to shear. Or, secondly, the bolts holding the sprocket onto the hub were insufficient in strength for the forces involved. Let's look at the sprocket first. The fit seems okay, not too slack. That is not going to increase the shear forces. One of the retaining washers, no movement marks. Now for the detent. The springs are quite strong. This movement that you can see is mostly my thumb being deformed. All the time I'm looking for any telltale marks that would indicate unusual wear. When you're sure the original grease does not help, then the part may be cleaned. The sides of the detents indicate that they've been under sideways force. But the tips do not indicate that they have moved at all. The inner bore of the hub shows no wear marks whatsoever. Now presumably, the designer of the overload clutch would have calculated the shear forces exerted on the bolt when the clutch slips. The clutch doesn't appear to have been slipping. This leads to a reasonable conclusion that the failure is bolt fatigue rather than simple shear force. Remember in part 1 when I looked at the bolt and said it looked like fatigue failure. Whereas the bolt shear force calculation is simple, more knowledge is required to perform a fatigue calculation, which perhaps, clearly, the designer didn't have or thought unnecessary. I'm not sure that I would have designed a clutch with so much clearance between the hub and the rotor. With this clearance, the rotor is centralized in the hub by the detents and spring. This clearance could possibly cause the hub assembly to have an extra load applied to it. I wouldn't know unless I do a calculation. It is much easier to replace the 8.8 quality bolts with 12.9 quality ones. In layman's terms, the 12.9 bolts are over half as strong again as the 8.8 ones. The 50 could be significant. It could be a load figure that can be increased by putting a larger or smaller number of loading springs down the middle of the detent springs. Or it could be a figure used internally by the factory to indicate the quantity of overload clutches they've made that day or week. We definitely require a fixture to compress these springs.